Hey guys! Alright, maybe you just read this webpage, maybe you didn't read the whole thing, it's pretty long, but I do want to talk about it, I want to dive into it, right? So what is this guy getting at? If you're not already a software developer, you may not know this, but there is a big sort of saying in software development, which is that the writer's time, the developer's time, is more important than computer time. What does that mean? Basically, if I tell you that you have to do 3 hours of work, you might not want to do that 3 hours of work. But if I tell you that your computer has to do 3 hours of work, you're like, yeah, sure, just have the computer do it. Sounds fine. Cool, good. I'm gonna go play video games, whatever. Okay, so we've got that concept, right? You're totally willing to let the computer do all the work, but you don't necessarily want to do it yourself. What does that look like in software development? What this guy gets into in this whole, blog post, whatever, is that it ends up meaning that the code that is written for web pages, for apps, for things like Slack, which you guys are using, for Gmail, which you guys use, right? For Facebook, for Instagram, for all these things, the software that's written, that runs these programs, ends up being really, really bloated. Right? Why is that? Because software developers will kind of just write something, make it work, write something else, we'll just kind of, jerry-rig it so this thing will work with this thing. You write something else, you add in a new thing, you do, okay, well that doesn't work with this part, so we just jerry-rig it again, right? And you have this idea of just sort of throwing in new pieces, more pieces, and just making it work, forcing it to work, but you're not really making it rugged, right? You're not making it streamlined, you're not making it as effective as possible. They don't go back all the time. Okay, some software developers, maybe most, whatever. A lot of software developers don't spend the time to go back. They're not even told to spend the time to go back and make the code shorter. Why does that matter? If you have a very long code, it means that the computer has to go through, let's say, 1,000 steps or 10,000 steps in order to execute the program. Okay, so the computer has to go through steps 1 through 10,000 before you get to see Slack, before it even shows up at all, right? And that can take the computer longer time, right? If you could do it in 1,000 steps, if the computer could only do 1,000 steps, it would be a lot faster. So what this guy's talking about in this blog post is, we could have faster technology, right? The time we spend waiting for web pages to load, the time we spend waiting for pictures to load, waiting for ads to load, which we don't even want ads anyways, waiting for our programs on the computer to load, waiting for Microsoft Word to load, to save, to do things, waiting for everything on our computer. We're waiting. If you have a Microsoft computer, you've probably experienced this. This is one of the things this guy mentions. It takes half an hour or more for Windows to update. And this guy's premise, his sort of statement, is what on earth is taking 30 minutes to do? What is the computer doing for 30 minutes? How many millions of steps does the computer actually have to go through in order for this update to take 30 minutes? That's an insanely long amount of time. Actually, the thing that he mentions there is that, some of this phrasing you might not understand, but he mentions in this article as well that he could basically reformat a hard drive and download a fresh version of Windows 10 5 times over in 30 minutes, right? So the most brand new version of Windows 10, he could just download it and then download it again and then download it again and then download it again 5 times in 30 minutes. So why is it that an update, which should be a relatively small change, okay, so it's not like downloading an entire operating system. It should be a small change, just a tiny update to your computer. Why on earth does that take 30 minutes? And so this guy's getting at that, right? But why is that? Because it doesn't matter if the computer has to do 10,000 steps. It doesn't matter if the computer has to do 10 million steps, because that's not human time. It's not the developer's time. The developer would have to spend maybe hours and hours, weeks, maybe even months, to cut it down so that your Microsoft update only takes 30 seconds instead of 30 minutes. But that would mean that it's human time spent, right? So it's kind of like the basic idea, right? Is that, okay, why would we take, all of these months, why would we spend so many months making an update that could actually happen in 30 seconds when whatever we have right now is basically fine? It gets the job done, your computer gets updated, so why are you complaining? It's fine. Yeah, it is fine, technically. But everybody hates that these, updates take a half hour. Nobody likes that. Nobody's like, yes, I'm so excited. Today I get to stare at my computer having a blue screen for 30 minutes while it updates. Nobody likes that, okay? And so this is where we come in, all right? This is why we're getting into this whole idea. Where we come in is when you're doing geometry, all right? When you're doing geometry, if you create a proof that's 800 steps long, yes, technically maybe it worked, okay? So you can create highly inefficient and ridiculous things that will technically work. But is the goal to technically work, right? The argument of the guy who wrote this blog is no, it's not. The goal is not just to technically work. The goal is not to just barely exist and create crap, just absolute garbage that slows down our computers. He talks about several times in this blog post that our computers technically require basically more and more effort to maintain the same level of speed, right? So because we're making it so slow, because the code is so cumbersome, right? We have to have better and better hardware, so the physical drives and things. We have to have better hardware just to make the software run at the same speed, right? Not any faster. So your computer's not getting faster. But why do you have to buy a new computer every couple of years? Because the hardware no longer keeps up with the bloated, just backwards, super slow, idiotic coding that's there, right? Just the coding that it's so cumbersome. It's so big. It's so bloated. There's no reason for that. So when you're doing geometry, what really is the reason for having a bloated proof? Usually it's laziness. That's pretty much all it is, right? If you don't want to do extra work, yeah, I get it, right? You don't want to take an extra hour or an extra 10 minutes or an extra 2 weeks or however long it would take to really genuinely figure out how to do your proof in a short, efficient way. To really understand the most efficient, the most effective way to get from your starting point, your given information, to the thing that you're trying to prove. Now, I understand that. Everybody's lazy. I got you. Okay, we're all lazy, at least sometimes, most of us, a lot of the time, right? Human ingenuity is actually driven by laziness, right? We created computers because we didn't want to have to go to libraries or something, right? We do these things. We create cars because we don't want to have to walk everywhere all the time. And so a lot of ingenuity is driven by laziness. That's great. But we also sometimes need to look at the real substance of the thing. And if you're just creating a proof just to have it basically exist, right? It's just, this is a garbage proof. I've put as little effort into it as possible. This is my garbage proof. Take it. If that's the mindset, one, you're probably not going to do very well in your geometry class because that's not what your teacher's looking for. Two, you're not going to get anything out of geometry at all because, as we've mentioned several times before, geometry is a system of logic. It is about learning logic, right? It's not about learning about shapes. It's not learning formulas. There's no formulas. That's not the point. It's about learning logic and a system of logic and how to build things effectively one on top of another. If you are building basically, just a ridiculous structure of bloated bricks kind of falling all over each other, technically, you might be able to pile up enough bricks that it reaches, an entire, floor, one story. But you're not really going to call that a building because it looks like garbage. So that's the whole kind of idea, right? It's like let's not build garbage. Let's not prove things in a lazy way. Let's not do it that way. We're not going to let you do it that way in our classes because that's not really what we're about. We really are very interested in your pursuing like actual logic and really learning logic. But so this article was just another way of, reinforcing this concept of, hey, as part of the world, everything that we create, let's stop being so lazy. Let's take pride in the things that we make. Creation, I've said this before, creation is a beautifully human thing, right? Maybe animals create nests and homes for themselves, but humans create way more than that. We are creative, amazing creatures, and to kind of treat that poorly, to treat creation like it's just nothing, is sad. I think it's sad. So, regardless, you have to do the shortest possible proof anyways. Those are our rules here. If you don't want to follow our rules, you don't have to stay, but I hope you stay, because we have rules that are good for a reason. So let's get back to it, and we're going to learn how to do whatever proof you're on in the fastest way possible.